Good morning, students. Today we are dealing with exercise 1.4. First question, prove that the following are irrational number. In this first question is 1 by root 2. Okay. In this we have to prove this one. We have to prove that prove that 1 by root 2 is a irrational number. Okay, first of all, let us assume that opposite, that is, we are taking 1 by root 2 is a rational number. Okay, first of all, what we are doing, 1 by root, in the question they gave us 1 by root 2 is a rational number. So what we are doing now, we are taking as a opposite to it. అంటే ఉల్టా తీసుకుంటున్నాం అన్నమాట. That is 1 by root 2 is a irrational number. Hence we can write as in the form of this equation we can write as a by b. Okay, where a and b is not equal to 0 are co-primes. That is, co-primes means no common factors. Other than one. Okay. Now, hence 1 by root 2 equal to a by b. Okay. Now, what we are doing? We are cross multiplication. That is, b equal to a into root 2. Okay, we are getting like this. Now we can write like this also. That is, root 2 equal to a by b. Okay, no. Okay, here root 2 is a irrational number. Here root 2 is equal to irrational number. A by b is rational number. Okay, root 2 is a irrational number. A by b is a rational number. By this one, since irrational number not equal to rational number, our assumption is wrong. This is contradiction. Our assumption is incorrect. So 1 by root 2 is a irrational number. Okay. Now second question. That is root 3 plus root 5. this is also we have to do in the same method. That is, let us assume root 3 plus root 5 is rational number. Okay, same as the previous sum. How we did this one? Same method. Hence root 3 plus root 5 we have to write in the form of a by b. A by b. Okay, where A and B is not equal to 0 are co-primes. Okay, hence root 3 plus root 5 equal to a by b. Now squaring both sides. That is root 3 plus root 5 whole square equal to a by b whole square. This is a square plus b square plus 2ab. A, b equal to, like that we will keep. This is 3 plus 5 plus 2 root 15 equal to a by b whole square. We are adding it. Plus 8 equal to a by b whole square. No. 2 root 15 a square by b square minus 8. I am sending this 8 that side, it becomes a minus. So 2 root 15 equal to a square minus 8b square by b square. Okay. No. I am sending this 2 down. That is root 15 equal to a square minus 8b square by 2b square. Here also same. Root 15 is a irrational number and this is a rational number. So rational number and irrational number are not equal. So our assumption is wrong. This is a contradiction. Our assumption is wrong. So root 3 plus root 5 is a irrational number. Okay? Next sum. That is root 5. This sum is different. కొంచెం వేరేగా ఉంటుంది sum. ఎందుకంటే same. We have to prove root 5 is irrational number. For this we have to assume, hence we assume root 5 equal to a by b. Same. Where a and b is not equal to 0 are co-prime. That is root 5 equal to a by b. Now First multiplication. A equal to root 5b. Here squaring both sides. That is a square equal to okay, and I can write as okay. Next step, b square equal to a square by 5. Here I can write like this also. 5b square equal to a square. By the theorem 1.4, by the theorem 1.4, 5 divides a square. Theorem 1.4, 5 divides a square. Hence by 5 divides a, now we'll take as C. Now here A equal to 5C. This will be take as a equation 1. Now we will substitute A value in this equation. Okay, we will substitute. No, before that we will do squaring both sides here. That is a square equal to 5c whole square. That is a square equal to 25c square. Without directly we can substitute there, or we will convert it and we'll do. That is, we are substituting a square in first equation. That is b square equal to 25c square by 5. We are getting b square equal to 5c square. Okay, I can write as c square equal to bc square by 5. In the same logic, here also, if we are dividing b square by 5, okay, if it is dividing b square by 5, it is divisible by b also. As 5 divides b square, it also divides b according to the theorem 1.4. Okay, now A and B have a common factor. Now A and B have a common factor as 5. Okay, it is contradict. It is not correct. That means it is a contradict. The fact that A and B are co-prime. According to our assumption, we are taking A and B as a co-prime. So it is that our assumption is wrong. This is due to the incorrect assumption, as root 5 is a rational, because we assume that root 5 is a rational and we solve this sum. But our assumption is wrong. So root 5 is a irrational number. Okay. Now, fifth question. That is 3 plus 2 root 5 is a irrational number you give. Same as we assume that 3 plus 2 root 5 is a rational number. That is rational number in the form of P by Q, where A by Q or A by B or okay P by Q, A by B, where A and B not equal to 0 are co-primes. Okay, now 3 plus root 2 equal to A by B. What we will do? 2 A by B minus 3. Okay, I am taking the LCM here. Now root 5 equal to, I am sending the 2 down. No, this is irrational number. This is rational number. So our assumption is contradict. That is irrational number not equal to rational number. So 3 plus 2 root 5 is a irrational number. Okay. Now second question and last question. Prove root P plus root Q is a irrational number. For this also we assume opposite of it. That is root P plus root Q is rational number. Hence, we have to show A by B form where A and B is not equal to 0 are co-primes. Now, so what we will do? Root P plus root Q equal to A by B. Here squaring both sides. Root P plus root Q whole square equal to A by B whole square, that is expanded. A square plus B square plus 2 AB equal to A by B. Now this is P plus Q plus 2 root PQ equal to A square by B square. Now here equal to A square by B square minus of minus Q. Now I am taking the LCM. Now I will send the 2 down all. Now root P root Q equal to A square minus BB square by 2B square. Here this is irrational number and this is rational number. So irrational number is not equal to rational number. So our assumption is wrong, that is contradicted. So root P plus root Q is a irrational number.